Welcome back to Chapter 3, Structure and Bonding, Section 3.7, Giant Covalent Structures. By the end of this tutorial, you will be able to explain the general properties of substances with giant covalent structures and explain why diamond is hard. We will begin by discussing giant covalent structures. Did you know that diamond is a form of the element carbon, the same element contained in your pencil lead? Diamond is the hardest known natural substance, and artificial diamonds, which are the ones that are synthetic, they can be made by heating pure carbon to very high temperatures under enormous pressures. Many covalently bonded substances are made up of individual molecules. However, some substances, like diamond, form very different structures. These do not have relatively small number of atoms arranged in a simple molecule. However, they form huge networks of atoms held together by strong covalent bonds, and this is what we call in a giant covalent structure. So diamond, it is a huge network of atoms in simple molecules, and here it is a network of carbon that we call a giant covalent structure. This is the structure of a diamond molecule. Having a giant covalent structure gives substances some very special properties. So giant covalent structures, they have special properties. First of all, they have very high melting points and boiling points. So substances like diamond, they are hard to melt down and they need very high temperatures in order to boil. Also, giant covalent structures, they are insoluble in water. So diamond, a piece of diamond, if you throw it inside a cup of water, for years it won't dissolve. Diamond is not soluble in water. And finally, they are hard and do not conduct electricity. For example, as mentioned earlier, diamond is exceptionally hard and it has a boiling temperature which is 4,827 degrees Celsius. Each carbon atom forms 4 strong covalent bonds, as you can observe here, which are arranged in a perfectly symmetrical giant lattice, as you can observe in the following diagram.